So we read the New York Times article that basically said that we can't say for sure if climate change is supercharging El Niños. When we say that, we are not being very specific about what aspect of El Nino may be changing. In general, we can say there isn't a very clear signature of climate change on El Nino characteristics, life cycle, etc. But there is one group that tries bravely to keep going with certain claims, and they offer some scientific arguments as well. You can't just publish claims as opinions. You can do that in newspapers, but when you want to publish in scientific journals, you have to provide analysis and reviewers look at it and tell you whether you make sense or not. So this group has been writing several papers on this topic, led by Wenju Chai, who was at CSIRO in Australia, but now is in China, Ocean University, I think, in Qingdao. Anthropogenic impacts on 20th century ENSO variability changes. So this is a different way of doing things where you start by looking at whether the historic period of the last century shows any change in ENSO that can be attributed to climate change. And then you go and look at the models to see if they are reproducing the observed changes in ENSO because of global warming. And then you say the models are good enough to go forward and project on what may happen as we keep increasing greenhouse gases and keep warming the climate. And in that, there are a couple of approaches. You can take the same model and make many simulations so that there is internal variability in the model itself, or you can take many models without worrying about their abilities in any sense, and it's kind of a democratic approach, and then look at multi-model ensemble, and we'll see what that means. So it's a nice long article, but I'm going to be very brief because I just want to make a few points. The abstract is also a bit longish, but we'll go through it. El Nino Southern Oscillation and so sea surface temperature variability increased after 1960. So this is a claim from data, but the data are from a reanalysis product or reanalysis products, which means they are data blended with models. Data is not continuous in space and time, and models can fill the holes and give you the best dynamically interpolated products, but there are some issues with them as well. Okay, so El Niño Southern Oscillation sea surface temperature variability increased after 1960, influenced by more frequent strong El Niño and La Niña events. So considering El Niño and La Niña alter the background state, variability can go up if there are more of them or more stronger events. Whether such changes are linked to anthropogenic warming, however, is largely unknown. In this perspective, we consider anthropogenic impacts on ENSO variability in several commonly used modeling designs, which collectively suggest a greenhouse warming related effect on post-1960 ENSO SST variability. So they historically, they use the historic period to establish some kind of an argument. Specifically, a comparison of simulated ENSO SST variability between 1901 and 1960 and 1961 to 2020 indicates that more than 3/4 of the climate models produce an amplitude increase in post-1960 ENSO SST variability, translating into more frequent strong El Nino and La Nina events. So more than 3/4, so there are some models who don't do that, and models are not necessarily all independent. They are different in some ways, but the core heart of the models tends to be very similar. Multiple large ensemble experiments further confirm that the simulated post-1960 ENSO amplitude increase of approximately 10% is not solely due to internal variability. So the large ensemble here is to basically take care of the fact that climate varies a lot by itself, internal variability. So SST variance may go up or down without any external forcing, just because you have long-term memory in the ocean. Atmosphere can pick up on it and dance around coupled interactions, or you may have other forcings like aerosols, whatever, and aerosols can be considered external forcing if they are coming from human activities, but they can come from volcanoes, which can also be considered external forcing. Any forcing, including human-induced greenhouse gas increases that alter the radiation balance at the top of the atmosphere, are called forcings. What is external versus internal? Internal is that solar forcing, volcanoes, everything have changed over the 20th century, but you can somehow separate anthropogenic impact. Okay, so that's the main point. Moreover, multi-century long simulations under a constant pre-industrial CO2 level suggest that the observed post-1960 ENSO variability is high, sitting in the highest 2.5 and 10 percentiles for Eastern Pacific and Central Pacific ENSO respectively. So 2.5% percentile change in the Eastern Pacific, is that significant? Well, that's the question. Mainly you want to see what does that mean in terms of the teleconnections and impacts on monsoon and other places. Improvement in model and so physics, identification of consistent future, and historical change in additional ENSO characteristics and single forcing large ensemble experiments are further needed to ascertain climate change impacts on the ENSO. So caveat is that this makes a certain analysis of historic time period and projects into the future and says the answer is not final, which is what we concluded before from the New York Times article. So I want to read all these details. Basically, they define a East Pacific ENSO index E index and Central Pacific ENSO index C index, and then there are some numbers of changes in them. So the E index and C index exhibit 31.8%, so 0.88 to 1.16, and 17.9%, so 0.9 to 1.12 increase in variance respectively. The increase in E-index variability is associated with the greater frequency of strong EP El Nino events from 2 events in the 1901 to 1960 period to 4 events. Is that enough of a sample? Well, this is what we have, so we are interpreting it as it is. By contrast, the increase in C-index variability reflects the greater frequency of strong La Nina years from 1 to 9 events. That looks like a big jump, with only a comparatively small increase in the frequency of CP El Nino events. There has been a debate about whether CP El Nino events have increased because of global warming, and this is basically saying there is only a small increase in the frequency when you compare these 2 half centuries. The increase in ENSO variability is largely consistent across reanalysis data sets that I mentioned, and there are paleo-based evaluations as well of increase in CP and EP ENSO variability relative to the pre-industrial era, including a 25% intensification of overarching ENSO variability, so all types, during the late 20th century relative to the pre-industrial period or distant past. Thus, reanalysis and paleo-based analysis suggest that anthropogenic greenhouse gas forcing might have already contributed to an increase in ENSO variability. Might have, so you have to always remember. However, determining the impact of anthropogenic warming on the observed ENSO SST variability is hampered by uncertainty arising from decadal to multi-decadal fluctuations of ENSO. So ENSO's cluster, which produce internally temperature changes and SST variability changes. If you have more ENSOs, you get higher variability, and more ENSOs can occur just naturally without anthropogenic forcing. Determining anthropogenic contributions to changing ENSO variability is vital to attribute causes of extremes, because ENSOs bring extremes. We will look at monsoon. Well, by the time you see this podcast, you would have already seen the one on monsoon extremes and ENSO. So they assess the possible impact of greenhouse warming, and they look at the model democracy, where all models are taken, and second is a single model large ensemble experiment where uncertainty due to internal variability is separated when you compare multiple models. The uncertainties or variability could be model structure differences, whereas if you take one model, then you are generating some measure of internal variability as depicted by that model, which is again different between different models. But nonetheless, multi-century long experiments under constant pre-industrial CO2 forcing by control are used to examine how unusual post-1960 ENSO variability is. Basically, they do all that is needed in this sense. I don't know why I have two of these. It's the same thing, but anyway. Here it is, DJF, that's the ENSO peak of the El Nino index in the cold tongue, and extreme El Ninos occurred there as well, as you can see, 82, 83, 97, 93, 97, 98, and 2015, 16, and there are some that went above some kind of a threshold as well. So strong Eastern Pacific El Ninos in red, E index, and Central Pacific El Ninos in the DJF C index. So you can see that, and there are strong Central Pacific La Niñas. So we discussed before and said maybe there aren't multiple flavors of La Niña, but slowly people are squeezing the data to separate them into a couple of flavors as well. Nonlinear relationship 1901 to 1960. So second principal component and first principal component. So you do El Nino first and second components. I should have probably read it, but you can go and read it. So there are some measures of nonlinearity on how independent the two EOFs are. In general, EOFs, when you compute them, you force orthogonality, but if they are not really independent, then you get muddled relations. But if they are really independent, then you get very strong anti-correlation, well, zero correlation between them, let's say, because they are orthogonal to each other. Okay, so reanalysis E index, I'm being very brief because this is a good topic, but I am basically in the camp that says we are still not at a place with, in terms of samples, data, and model reliability, to say climate change is really having an impact. Okay, I should make that clear. So reanalysis E index variability, various experiments, various models, and products. So HADA, SST, COBE, multi-product ensemble mean, and so on. So standard deviations for pre and post 1960 argument is almost all of them show an increase in standard deviation in the E index variability for the post 1960 period, and similarly for the C index variability. So these are various reanalysis products. ERA is here. Anyway, you understand. So the same thing here. So you can see that maybe this jump is a bit larger than here, but depends on the product. So HADA SST, for example, shows relatively larger variability in E ENSO, but C ENSO variability, while larger, is not as large as the E index variability. So the idea is that C index didn't change that significantly. There is a this is the caption for the whole thing. So this is A, B, C, D, E, F, and these are the captions that I'm not reading at all. But here is another one which is looking at figure 2, nonlinear relationship. So in simulated increase in post-1960 El Nino Southern Oscillation variability, E-index standard deviation for the two periods from 43 available coupled model intercomparison projects in CMIP6. Gray shading indicates models that do not simulate an increase in El Nino Southern Oscillation variability, with a percentage of models that simulate an increase denoted on the top right. So it's the same thing but being done with models, and you have some models that go in the other direction. So we are looking at pre and post, and there are models with a decrease in ENSO variability in the post 1960 period. So you can see which they are. So this is for E ENSO. So there is a 76.6% consensus among all the models considered. For C index variability, there are many more that have the reverse as well. So C index was higher before 1960 and lower during post 1960, whereas others 62.8% consensus that C index variability also increased in the post 1960 period. What do you do with this? You just say that most models agree, hence we can trust the models to do future analysis. That would be the main point, saying they're consistent with observations, so they are reliable. Let's leave it there. Okay. Nonlinear relationship for 1901 to 1960. Models have a much more of a spread between first and second EOFs. I think maybe I should say clearly what the first and second EOFs are. So let me get the exact wording from the paper so that I don't muck it up. Okay. Okay, so it's worth mentioning this. I skipped it because the paper itself doesn't define it very clearly. But in general, when we say ENSO nonlinearity, we are talking about how El Niños can be typically much stronger than La Niñas, impacts are asymmetric, and so on. So El Niño and La Niña are not mirror images in this sense, but here they are looking at first and second principal components of the tropical Pacific SSTs and looking at the first period and the second period in terms of the strong La Niñas, strong Central Pacific La Niñas, and strong Eastern Pacific and Central Pacific El Niños. And we already mentioned how there were only two strong Eastern Pacific El Niños in the first period that jumped to 4 here. La Niñas went from 1 to 9, and Central Pacific didn't change that much, and you have lots of these in the middle. Okay, so this is a measure of nonlinearity in this sense, which is repeated here. So you can see that when you look at because you are using many more CMIP6 models, obviously you got many more points, and the idea is to again see if they can do jumps in strong La Niñas, strong Eastern Pacific El Niños, strong changes in Central Pacific La Niñas, and Central Pacific El Niños. Okay, so obviously data is limited in that sense in terms of number of El Niños, La Niñas, and Central Pacific El Niños, East Pacific El Niños, and so on. So the idea is to just convince yourself that models are generally capturing the changes in the frequency of El Niños and La Niñas, and also the nonlinearity as defined here. Okay, so E index in 7 large ensembles. So you are looking at now same model, and you are looking at number of number of ensemble members, let's say, that are showing increased and decreased number of El Niños, La Niñas, etc. from 1901 to 1960 to 1961 to 2020. These are the various models, and you can see E index change owing to greenhouse gas warming, and El Niño Eastern Pacific El Niños, we already said what the data is doing and reanalysis are doing. Now we are looking at models. Well, let's say some of them show an increase, but none of them are as dramatic as the data or the reanalysis, as we call them. Reanalysis are often called data, but remember they are models blended with data, not just data. So these are the C index, and as the strength of, so I won't even bother with these things. Okay, so let's just jump ahead. This is the high variability of the post 1960 El Nino Southern Oscillation. Now we are only looking at 60-year standard deviations, and 90% level, 95%, 97.5%, where the observed 1960 and 1901 to 1960 and 1961 to 2020 stand. So here is the first period, here is the second period. So obviously observations show significant differences according to the analysis presented here with reanalysis, and you can see what the models do in terms of E index and C index. Let's just jump ahead and read the conclusions. I included all the figures thinking maybe it's important, but I will just skip them. And here is the more interesting part where they are going to after convincing themselves that models are good enough to do this, they go into the future. So evolution of strong El Nino frequency in different experiments. Pi control is where you have pre-industrial CO2 forcing. So you have how the historical change is seen in terms of frequencies per year, and then you do a scenario. SSP 5, 8.5 is business as usual, and you may remember that IPCC has basically scratched this because they say this is no more a possible scenario because everybody is doing enough for climate mitigation. And similarly, this is for strong El Nino, for strong La Nina, a clear increase in the worst case scenario, but much more up and down here in the so there was a decrease during the 1901 to 1960 period, increase during the 1961 to 2020 period, and then you have projections which show some increase but not as monotonic as here. Okay, so past, present, and future E index variabilities. Continued increase in some models, so this one didn't increase much in the historic period but jumps in the future a bit. This is going up continuously, continuous. This one even goes down. IPSL is the French model, Miroc is the Japanese model, jumps in the post 1960 but doesn't jump much further for 2041 to 2100. The other detail here is that in the first couple of decades, let's say out to 2040, model uncertainties and internal variabilities are the dominant factors in the uncertainty, but beyond that, scenario uncertainties are the most dominant influencing factors. And looking at what's happening in the world, you can imagine that it's not easy to imagine scenarios. They could be way off. Okay, so past, present, so more models for the C index. This is for E index and C index. Take them for what it is worth. Let's just look at what explanation they offer. Collectively, these different approaches suggest that a post-1960 increase in ENSO variance likely attributed to anthropogenic warming, likely. So faster warming in the East in part results from a rectification of the increase in ENSO SST variability onto the mean state. In the real world, Eastern Pacific is warming less or even cooling in the reanalysis products, or what we would call observations, but most of the models are not able to capture this, and there are a series of papers trying to understand why models are failing to capture this, and we are using these models to do ENSO variability and convincing ourselves that it's okay. They're doing okay. So how the background mean state errors impact ENSO and ENSO variability? You have to figure it out for yourself. So the mechanism behind such an increase is similar to that responsible for the projected ENSO shifts, namely changes in ocean stratification. In response to increasing greenhouse gas emissions, the upper equatorial Pacific exhibits enhanced mean vertical stratification. So as you warm near the surface, the stratification density gradient gets stronger. So mixing, Biekner's feedback, the whole show of El Nino life cycle will change, so SST variability is changing. The faster near surface warming is a result of greenhouse gas induced radiative forcing and increased precipitation related freshening, so mixed layer physics changes. Both enhance the response of the sea surface mix layer to a given wind forcing, strengthen ocean atmosphere coupling, and contribute to a greater sensitivity of tropical Pacific SSTs to forcing from extratropical Pacific variability such as Pacific meridional mode, even though its own variability does not necessarily change. So detailed interpretations of what has happened and why this will happen also in the future. Should we take it seriously? So I don't know. Let's just jump to summary and future perspectives. In a single realization of the real world with limited observations, it's difficult, if not impossible, to determine whether observed ENSO has been affected by rising greenhouse gas emissions, even if quality of the available observation data was not an issue. So they say Rienhouse products are good enough, but only one realization means Mother Nature did something. We don't know how many things she could have done. In the model, you can produce large ensemble, which means multiple realizations for the 20th century, whereas Mother Nature gives one realization. But nonetheless, we are not sure exactly whether ENSO has been affected by rising greenhouse gases. However, model outputs from multi-century long pre-industrial simulations of constant CO2 forcing and historical simulations forced with observed forcing and future simulations under emission scenarios offer a valuable resource to ascertain greenhouse gas forcing impact on ENSO. A model democracy approach indicates that anthropogenic climate change has generated a statistically significant increase in ENSO SST variability between pre-1960 and post-1960 period. This increased variability features more frequent occurrences of strong El Nino and strong La Nina events in the post-1960, but little change in CP and so on. So the realizations give you 25,868 years of pre-industrial virtual climate which further highlight that observed ENSO variability is unusually high in the post-1960 period. So various ways of ascertaining that what reanalysis products indicate is beyond internal variability. In terms of climate model assessment, examinations of simulated future changes in additional ENSO properties, for example, ENSO onset, termination, and seasonal phase locking offers another pathway. A future change in any additional property of ENSO, if also seen in both the simulated and the observational post-1960 ENSO, would provide additional lines of evidence. Okay, nonlinear Bleakness feedback amplifies ENSO response to greenhouse warming such that models simulating a greater feedback systematically generate a greater ENSO enhancement, improved parameterization of atmospheric convection, cloud formation and their coupling to ENSO processes, leading to a realistic nonlinear Bleakness feedback will potentially strengthen the simulated post-1960 ENSO enhancement and the intermodal consensus. Okay, well, Wenju is a believer. He is convinced that ENSO is changing because of greenhouse gas warming. So I don't want to say anything negative, but you have to be careful when you are driving a hypothesis and find evidence to confirm your hypothesis. And there are enough caveats. They do use words like likely and uncertain and maybe and so on. So keep that in mind. And ultimately, we need to just understand how the teleconnections are changing because of global warming. Okay, let's leave it here.